everybody in Physics 100. This is Dr. Ricardo. It is Monday afternoon, 2 days before our lab on Wednesday. It is the 19th of April, so that's going to go on your report sheet. And what I'm going to do outside is I need to do part 1 of our photovoltaics lab. So this is the data sheet that I'll show you once we go back inside, okay? And the first thing that you want to fill out is it has the date. So you want to put 4/19, and then the time, it's 4:20 p.m. Okay, and if you look, we're going to scan around and we're just going to give you an orientation of where we are, because what we're going to do is take down some data about how much photoelectric energy we're able to pick up on a sunny day in April. So one of the things that you're going to do on the bottom, and we'll talk about it once we go inside, is you're going to draw a bird's eye view of the placement of the solar cell in the field. So right now we're actually outside my house, okay? So we're gonna point down at the solar cell. The sun is coming up, just point to the sun, is coming up that way. And then here's my house, and then you can scan around and I'll give you a perspective. It's coming in over the trees. You can go, and then John, just go all the way around the block, nice and slowly. Okay. All right, so that's what it looks like looking from the trees. And then once he gets back to the original spot right there, he's just going to go down and go eye level and go all the way around. So basically, guys, behind the solar cell, you've got a row of houses. In front, you have a street, and then houses across the street that you could draw all the way up the block, and then, like you'd expect, more houses over on this side, so you can just kind of draw houses and trees. Okay? All right, so that's the bird's eye view. I'm going to give you an idea of which way the solar cell is pointing to pick up the maximum amount of light. And then the last thing we're going to do before we take our reading. So if I want to point this directly into the sun now, okay, I'm just going to look, and that looks just about right. So hang on 1 second and I'll give you that reading. Okay, so right now, the back of the solar cell is pretty much this way, is straight looking east. Okay, so that way is straight looking east. I'm going to turn around. Behind the solar cell is pretty much looking straight west. This way, between those two, is north, and then back behind you right now would be south. Okay, so the solar cell is pointing basically straight east. So that compass direction is 90 degrees. So the compass direction that you want to put down is 90 degrees east. Okay? All right, so next thing that we're going to do is we just have to find out what the maximum reading is on here. We're going to take the voltage reading in millivolts, okay? And then we're going to calculate the current, so we can do that when we go upstairs, and also calculate the power. So we need to maximize the voltage. So what I'm going to do is I'm going to attach a voltmeter to it, and then I'm going to move it around until I get the highest reading. So when I get the highest reading, that means it's collecting the most sunlight. Okay? So I'm going to take my red lead, which is positive, and I'm going to put it on the solar cell across what is the load. Okay, so this guy, and I gotta have, it might be sitting on it, should be a red one someplace. Okay, hang on 1 second. So I'll attach the black one first, okay? So the black one is negative. So this guy's going on here. Okay. It's a very small amount of voltage and current on a panel like this, so you don't have to worry about getting electrocuted or anything like that. Okay, so that guy's going to go on there, and this guy's going to touch on the black side of this resistor. So this resistor is basically kind of acting as our load. What do I mean by the load? What we're trying to put the energy to. Like for instance, this could be our heater, or it could be our radio, or a computer, or whatever it is we're trying to power up. You have to have a load in order to do that. Okay, so since I'm missing one cell here, or one thing, I'm just going to place this guy where it's touching. Okay, and I should be, oh yeah, that guy's good, and that guy is good. Okay, so hey, how are you? Okay, so you take a look at this guy right now, right, and we're going to do a little bit of trigonometry to get the maximum number. But this is reading in millivolts right now. Okay, and I'm just going to move it around. Make sure I have a good contact. Okay. So you see how it's going down. So I'm getting less voltage. It should go to 0 now. And pretty much 0 once they're touching each other. Okay, so that's pretty much 0. So then this guy, when it's touching over here, I just want to raise it up until I get the highest number. But let me make sure I have all a good contact here. This guy is reading voltage. Oh, there you go. That's a pretty good reading. So you guys take a look at that. That's 1.53 volts. Okay, so that's a pretty good reading. So I'm gonna take it off, and you can see that number drop down to pretty much 0. So you know I'm not faking it. And then when I put it on, I go back to 1.47. So now what I'm going to do, last number I need, is I want to get what angle is the best angle to pick up this light. So I'm going to go up and down and try to max out that number. So I'm up to 155. Now it starts to go back down. 152. See, it went down to 148. So I go back down this way, and it looks like I can't really get any higher than when I had it right about there, 146. See, if a cloud comes in the way, we also have that sort of changing. So I'm gonna take it right, looks like right about that's in the 30s, so I've been higher than that. Right? I want to go a little bit lower. Here you go, right there, 136, 137. I think that's about the maximum I can get. So what I'm going to do is just stick the pencil in the ground to hold it up at that angle, okay? We're gonna do the rest when we go upstairs. So at that angle, I just have to take one more measurement. So we're gonna do a little bit of trigonometry. If I want to get this angle down here, guys, right? And this is a right angle, and I know this length. And if I measure this height, I can use trigonometry because the tangent of the angle here is going to be equal to the opposite side over the adjacent side. So the length of this board is 21.5 millimeters. So the only other measurement I have to take, and the rest will be calculation, is I just need to measure how tall this guy is. All right? How far it is off the ground. So this is going to 45, and this is going over here to pretty much 30. So this is 15, okay? So what we have is the opposite is 15 divided by the adjacent, which is 27.5. So remember that, 15 millimeters over 27.5, and we'll do the math once we get to class, okay? So we have opposite over adjacent, 15 over 21.5, and we have our maximum voltage, which you can write down now, which was 1.41 volts. Okay? Thanks, guys. We'll see you back when we're in class.